Federated learning is a way to securely develop AI models by distributing them to different environments without having to gather dispersed data in one place. When building models to be used across organizations, this method is used to share models between organizations, while avoiding directly transferring data between organizations, which advances data use and protects privacy at the same time. Obtaining better data in terms of both quality and quantity is essential to succeed in data science. As an approach on how to acquire and organize data, federated learning is expected to utilize large amounts of high-quality data by collecting data across organizations. Leveraging data across organizations requires the implementation of analytics technologies that consider the protection of data privacy. There are two ways to achieve it. One is secure computation to share encrypted data between organizations, and the other is federated learning, which is a way to share models. Secure computation provides a high level of encryption for data, but data is transferred between organizations. In federated learning, on the other hand, the basic idea is to build a system that avoids transferring data directly and shares only the necessary information to update the model. Federated learning is an AI system where different participants jointly manage a model, avoiding sharing data directly between organizations. Specifically, the learning process of AI models in federated learning is performed in the following cycles. 1. Distribute AI models. 2. Learn AI models in client environments. 3. Update AI models on a central server. 4. Distribute the updated AI models. 5. Update the AI models in client environments. It is believed that data to be transferred in the process of federated learning is not raw personal or sensitive data, but erroneous information and model parameters required to update models, enabling secure model building. Specific applications of such systems include AI-powered detection of fraudulent transactions at financial institutions. Multiple financial institutions similarly perform the work of detecting fraudulent transactions. On the other hand, if individual financial institutions develop AI models independently, the development of the model will be hindered due to the small number of fraudulent transaction data and the presence of data bias. Therefore, methods such as federated learning are expected to ensure sufficient data and efficient modeling in the industry as a whole. Other examples include insurance assessment, medical care, and autonomous driving. In general, federated learning can be effectively utilized by being applied to situations where individual organizations do not have enough data for modeling, and where integrating data across organizations ensures data quality and quantity. Although many parties consider implementing federated learning, the following are recognized as issues related to IT systems, AI model development, and ecosystems. IT system. Clients need to build a computing environment using AIs. AI model development. It is concerned that the accuracy may be lower than when using only in-house data. Ecosystem. The benefit of participating in federated learning is inversely proportional to the amount of data the organization has. As a technology that enhances data analysis, federated learning is expected to be applied to various fields. In particular, in areas close to social infrastructure, it is expected to reduce costs for similar work performed across the industry in common. The use of federated learning involves issues related to technology and system operations. However, selecting appropriate solutions suited for the desired system is expected to make more parties opt for federated learning.